Right, Nana. Good evening, good morning, good afternoon. Right. In our previous videos, we discussed about the ray diagrams on concave mirror and a convex mirror also. So today we have to discuss about that ray diagrams on convex lens and after that concave lens. So today we have to discuss about that ray diagrams. Right, Nana. Ray diagrams on convex lens. Ray diagrams on convex lens. Ray diagrams on convex lens. Now, before going to discuss that convex lens ray diagrams, whatever it may be. So, what is meant by convex lens? What is meant by convex lens? Okay, convex lens. Okay, right. Now, before going to that, what is meant by lens? So, lens is transparent material. Lens is a transparent material bounded by two surfaces in which of them two surfaces at least one should be curved. Nana. Ante if it is a transparent material and it is bounded by two surfaces, however, in that two surfaces at least one should be curved. ఒక్క సర్ఫేస్ అయినా కర్వ్డ్ సర్ఫేస్ అయి ఉండాలి. Then such type of transparent material is nothing but lens. Otherwise it is called as glass slab. Okay. So if two surfaces are plane surface, then for example this is the transparent material. It has two surfaces. So in these two surfaces both are plane, then it is not called as lens. It is not a lens. It is called as glass slab. It is called as glass slab. So what is meant by lens? Any transparent material bounded by two surfaces, which of them at least one should be curved. At least one should be curved. Both should be curved, maybe both are curved, or at least one should be curved. Then such type of transparent material bounded by two surfaces is called lens. Okay. Nana, ఒక్క సర్ఫేస్ అయినా one surface అయినా curved surface అయి ఉండాలి. Then that only we can call as lens. Okay. No, these are different types of lenses are there. Now we are discussing about that convex lens. So convex lens, the diagram of convex lens is like this. So this is the convex lens. Okay. Convex lens. This is the transparent material, clear, bounded by two surfaces, clear. Okay. Bounded by two surfaces. So in these two surfaces are bulging outwards. Two surfaces are curved and two surfaces are bulging outwards. Bulged outwards or bulging outwards. Okay. Such type of lens is called convex lens. Okay. In this convex lens, middle is thicker when compared to the edges. These are the edges. This is the edge and this is the edge and this is the middle part. So the lens which having thicker in the middle and when compared to the edges, such type of lens is called convex lens. So it is nothing but also called as both surfaces are bulging outwards. That's why it is called as double convex lens. Double convex lens because both sides bulging outward. both sides convex surface. That's a double convex lens. It is okay, it is generally called as simply or generally called as convex lens. Convex lens. So this is called as the double convex lens or convex lens, simply convex lens. So whenever if there is a convex lens means double convex lens. Understand? So it is thicker in the middle and thinner at the edges. So edges thinner పల్చగా ఉంది, that means thicker. So thick గా ఉంటుంది, edges thinner and middle thicker. Such type of lenses are called convex lens. So convex lens అని ఎక్కడైనా ఇస్తే then we have to take this type of lens. Okay, right Nana. So small information about this convex lens. Convex lens also called as the converging lens. Convex lens is also called as the converging lens because when all parallel light rays are incident on that convex lens, this convex lens converging all parallel rays. Okay, converging all parallel rays or converges all parallel rays which is incident on that convex lens. That's why it is also called as the converging lens. Clear? So this is about basic information about the convex lens. Okay, right now. So lens means transparent material bounded by two surfaces, which of them at least one should be curved. Okay, and such type if convex lens means both transparent material and bounded by two surfaces and bounded by two convex surfaces, such is called the double convex lens, or simply generally it is called as convex lens. So convex lens figure is this one. This convex lens thicker at the middle and thinner at the edges, and it is also called as the converging lens. Okay, now we are discussing about that, or let us discuss the ray diagrams on this convex lens. Okay, right? So what is the use of ray diagrams? Ray diagrams are useful to find the position of the image and the nature of the images. That means how the images are formed on the lens. That means how can the lens form the images? We can discuss by using the ray diagrams. Clear? Right, Nana. So as usual, there are some rules to draw the ray diagrams on convex lens or concave lens, whatever it may be. So there are some cases, and the rules means first rule is if it is the convex lens, simply I can explain easily. If it is convex lens, if any parallel ray which is parallel to principal axis after refraction passing through the focus point. This is the optical center. So it has focus point, center of curvature are also represented by the 2f1 and another focus point second side and 2f2. Okay. So okay, right. So in other video you can see these all what are the terms related to convex lens or concave lens and the terms and their definitions. So one more video you can see. Right, coming to the point. So if any parallel ray after refraction passing through the focus point, this is one rule. Okay, and one more rule is we have to use if any ray optic center focus point and 2f1. So focus point and 2f2. If any ray which is passing through the optic center, any ray which is passing through the optic center, it is undeviated. It is undeviated. There is no deviation. It is directly passing like this, undeviated. Okay, right? Clear. Next, one more ray we can take. Okay, so optical center, the focus point, and the 2f1. So f2 and 2f2. Okay, that is the third rule. So now if any ray passing through the focus point, for example this one passing through the focus point and incident on the lens, then what happened after refraction, it is parallel to the principal axis, right? What these are the three rules to draw the ray diagrams. So we have to mostly use this one and this one. First ray should be parallel after refraction passing through the focus point, and the second ray should be passing through the optic center. We know that it is undeviated. We have to use these two rules to draw the all cases. Okay, right, ma? So we have to take these two rules because to get the image to complete the image formation, we need at least two rays. Am I right? At least two incident rays. Okay, so mirrors lo kuda chuse at least two incident rays after reflection they are meet at one point, then we get the image at this point. Okay, right? So these are the three rules. So let us go to case 1, case 2, case 3, like that. Different positions of the object in front of the convex lens. Right, Nana? So you know that what is meant by lens, what is meant by convex lens, and what is the shape of convex lens. Okay, right? What are the rules to draw the convex lens? Now coming to the point. Right, first case, case 1, case 1, case 1. So when object is placed at infinity, when object is placed at infinity. So this is the first case. An object is placed at infinity. Right? Let us take the convex lens. So this is the convex lens. This is the principal axis. So it is the optic center and it is the first focus point, and this is the center of curvature, nothing but 2f1 we can indicate. No, C1 or 2f1, whatever it may be, you have to take. Okay, and the second side, so this is the focus point, second focus point, and obviously center of curvature or 2f2 also indication. 2f2 తో indicate చేయొచ్చు, otherwise C2 తో indicate చేయొచ్చు. Okay, right. Now object is placed at infinity. Right, Nana? Object is placed at infinity. You know that if any object is placed at infinity, that means far distance నుంచి వచ్చేటటువంటి rays whatever it may be, those are parallel rays. Okay, so that's why object is placed at infinity means first ray I am taking like this, so parallel to the principal axis. So after refraction, we know that according to the first rule, after refraction any parallel ray passing through the focus point. Okay, passing through the focus point like this. This is the incident ray and this is the refracted ray. Okay, right, Nana? We need two rays. Second ray you should take here also or otherwise here. Let us take here. Okay, second parallel ray, which is coming from the infinity object, placed at infinity. So after refraction it is also parallel ray, after refraction it is also passing through the focus point. Okay, these two refracted rays meet at this point. Am I right? Two refracted rays meet at that point. That's why image is formed at here. Now let us write characteristics of image. Nana, characteristics of, right now, characteristics of image. Okay, characteristics of image. Okay, right. First one, we need to write the position of the image. Now, where it formed, where is it formed? It is formed at f2. So image, image is formed at f2. Okay, image is formed at f2. And the second one, size we have to write size. So diminished, highly diminished, highly diminished, or point sized image also we can call it. Point sized image. And third one, no, it is the inverted image. Actually, it is point we can't identify it is inverted, but it is inverted little bit. So fourth one, real image, because of it is formed by the director lines. Real image. So when object is placed at infinity in front of the convex lens, the image is formed at f2 and highly diminished or point size and inverted image and real image. Okay, right, Nana? So you can note down, you can pass it and note down. So let us go to discuss about that case 2. Okay, clear? Okay, right, ma. Is it okay? Yes. Right, Nana. So when object is placed at infinity, characteristics of image is formed at f2, highly diminished, point size, inverted and real image. Real and inverted. Right. Let us write case 2. Case 2. When object is placed beyond 2f1, that means beyond center of curvature, placed beyond 2f1 and beyond 2f1, that means beyond center of curvature. Okay, right. Let us take the lens. So this is the lens and it is the principal axis obviously, and it is the optic center, and let us take focus point, first focus point, and 2f1 2f1, and let us take it is the focus point, second focus point mean, and 2f2 2f2. Okay, no, you have to take these distances are equal, then you can get the correct image positions. Okay, so you have to take equal distances, right? An object is placed beyond 2f1, so beyond 2f1 means beyond 2f1, 2f1 ke avatala. So let us take one object like this. Okay, this is the object, this is the object. Okay, let us take that is the object. Okay. Right, ma. First ray should be parallel from the top of the object. Let us take first ray. Okay, according to the first rule. So first ray parallel to the principal axis. After refraction, we know that it is passing through the focus point. So you have to use the scale and to draw. It is passing through the focus point like this. Okay, you have to use the scale and draw properly, then you get the correct image positions. So that is the first refracted ray and incident ray. No. Second one, obviously, for all ray diagrams, you have to use the same two diagrams, two rules. First, parallel refraction passing through the focus point after. So second ray passing through the optic center. Okay, then it is undeviated simply. So second ray passing through the optic center. Okay, second ray passing through, you have to use the scale. మీరు స్కేల్ యూజ్ చేసుకొని డ్రా చేసుకోవాలి. ఓకేనా? సో సెకండ్ రే పాసింగ్ త్రూ ది ఆప్టిక్ సెంటర్. ఆఫ్టర్ రిఫ్రాక్షన్ it is undeviated. It is undeviated like this. This is the incident ray, this is the refracted ray. Okay, so it is undeviated. So after drawing two diagrams, two rays, so these two rays meet at this point. We know that this gives the image position. This gives the image position. That means image is formed at this one. This is the image position. Okay, clear? Right, now let us write characteristics. Okay, let us write characteristics here. Characteristics of image. Characteristics of image. No. Tell me first one. First one, where the image is formed. You have to write the position. So first position of the image where it formed. It is formed between F2 and. So image is formed. Image is formed between F2 and 2F2. Between F2 and 2F2. Image is formed between F2 and 2F2. Next, size, nana. Size. Image size is compared to the object. Image size should be diminished. Actually, it should be little bit size compared to the object size. Image size should be less. That's why diminished image. Diminished image. Diminished, nana. If you are using the scale and you can draw properly, the size will be less when compared to the object size. And third point, nature. Third and fourth points are nature of the image. No, nature of the image. You can understand this is the inverted. So inverted image. inverted, and fourth point real image. So real and inverted image. So when object is placed beyond 2f1, so image is formed between f2 to f2 and diminished and inverted and real image. Okay, clear? Right now. So pass cheskoni, then you can write in your notebooks. Okay, right? Let us go to third case. Okay, right now. So check it once. Right now. Let us go to case 3. Let us discuss case 3. So case 3. And just when object taken into forward, that means an object is placed at 2f1. Next case 3. When object is, so case 3, when when object is when object is placed at 2f1, that means at the center of curvature. When object is placed at 2f1, that means exactly at the center of curvature. So let us take this one. So this is the lens run. So principal axis. Okay, obviously we know that optic center. Okay, optic center, and it is the first focus point f1 we can take, and the same distance we have to take, it is the 2f1. Okay, then let us take, it is the f2, and it is the, we can write 2f2. Okay, done. So object is placed at 2f1. Okay, right now. Right. So object is placed at 2f1 means here. So let us take object. We have to take the object. This is the object placed at exactly 2f1. Now first ray should be parallel as usual. First ray. After refraction, it is passing through the focus point. You can draw the line like this, focus point. Okay, right now. Second ray, it is passing through the optic center, so undeviated we can draw. So you can draw like this, optic center. It is undeviated. Okay, it is undeviated. So this is the second refracted ray. Second incident ray, after refraction, it is undeviated because it is passing through the optic center. Nana, optic center నుంచి వెళ్ళేటటువంటి ఏ రే అయినా, వాట్ ఎవర్ ఇట్ మే బి ద రే విచ్ ఇస్ పాసింగ్ త్రూ ది ఆప్టిక్ సెంటర్, ఇట్ ఈస్ అన్డీవియేటెడ్. డీవియేషన్ ఉండదు, రిఫ్రాక్షన్ జరగదు. దట్ మీన్స్ ఈ కాన్సెప్ట్ మొత్తం కూడా రిఫ్రాక్షన్ కాన్సెప్ట్. రిఫ్రాక్షన్ అంటే బెండ్ అవ్వటం లైట్. సో ఇక్కడ ఈ రిఫ్రాక్టింగ్ సర్ఫేస్ నుంచి ఆప్టిక్ సెంటర్ నుంచి వెళ్తే ఇది రిఫ్రాక్షన్ ఉండదు. That means directly it is passing through the, so straight ray. That's why when any ray passing through the optic center, it is undeviated. Okay, done. So these two rays meet at this point now. These two rays meet at that point. That's why from this we can write image is upward direction like this. So let us take 2f2 here. That point is this one only. Point is this one only. That's why. So this is the image. Okay, clear? Object and image. Actually, Nana, object size, image size, both should be same. Object size, image size, both should be same when you are using the proper scale. Okay. So మీ స్కేల్ తో కరెక్ట్ గా డ్రా చేసుకుంటే ఈ సైజ్ సేమ్ వస్తుంది. ఆఫ్ కోర్స్ లిటిల్ బిట్ నేను బై హ్యాండ్ తో డ్రా చేయడం లిటిల్ బిట్ ఇది బెండ్ అయ్యి ఉండొచ్చు. సో కరెక్ట్ గా ఎగ్జాక్ట్ గా వెళ్తే ఇది ఇక్కడికి వస్తుంది, సేమ్ హైట్ వస్తుంది. ఓకేనా, రైట్. సో క్యారెక్టరిస్టిక్స్ ఆఫ్ ఇమేజ్. Characteristics of image. Right now. So first we need to write the position. So first where it is formed at the image. No, image is formed at exactly 2f2. If object is placed at that position, center of curvature, image is also formed at the center of curvature. So second one, size, size, same size, same size as that of object. సేమ్ సైజ్ యాజ్ దట్ ఆఫ్ ఆబ్జెక్ట్ మీన్స్ ఆబ్జెక్ట్ సైజ్ ఎంత ఉంటుందో ఇమేజ్ సైజ్ కూడా అంతే ఉంటుంది. నెక్స్ట్ థర్డ్ వన్ యాజ్ యూజువల్ ఇన్వర్టెడ్ ఇమేజ్. మనకి క్లియర్ గా కనిపిస్తుంది ఇమేజ్ రివర్స్ ఫార్మ్ అయింది. దట్ మీన్స్ ఇన్వర్టెడ్ ఇమేజ్. Below the principal axis it is formed. And fourth one is real image. Real image. So these are the characteristics of image formed when object is placed at 2f1. Okay, next case object ని ఇంకొంచెం ఫార్వర్డ్ మూవ్ చేస్తాం అంటే ఆబ్జెక్ట్ పొజిషన్ 2f1 and f1 we have to take. Write down. So write down, this is the case 3, object is placed at 2f1. Okay, done. When you are drawing the ray diagrams, you should remember మార్క్స్ పోకుండా ఉండాలి అంటే స్టేట్ బోర్డ్ ఎగ్జామినేషన్ లో ఈ రేస్ కి యారో మార్క్స్ ఇంపార్టెంట్. యారో మార్క్స్ కంపల్సరిగా రేస్ కి అప్లై చేయాలి. సో ఇన్సిడెంట్ రే, రిఫ్రాక్టెడ్ రే. ఓకే, డన్. ఓకే, రైట్ మా. నెక్స్ట్, సో లెట్ us go to case 4. రైట్, what is the case for? Case 4. So object position will be changed like 2f1 f1. So when object is placed between, and when object is placed between 2f1 and f1, 2f1 and f1, when object is placed between 2f1 and f1, 2f1 and f1. So let us draw the diagram. Let us draw the ray diagram. So lens none, principal axis, focus point, sorry, optic center, and focus point, and this is the center of curvature 2f1, and this is the second side focus point, and again center of curvature 2f2. Okay, done. Second focus point, center of curvature 2f2. Right now. Okay, when object is placed between 2f1 and f1, object placed between 2f1 and 1. So let us take, this is the object placed between 2f1 and f1. Okay, object, this is the object. Okay, right. First ray should be parallel, we know that. After refraction it is passing through the focus point, obviously, as usual. Okay, right. Second ray, let us take second ray passing through the optic center, it is undeviated, we know that. So second ray should be this one. So passing through the optic center, it is obviously undeviated. Okay, it is undeviated. Okay, right. So here these two rays are meet, so that's why here the image is formed like this. Where the two refracted rays are meet, their image is formed. There the image is formed like this. This is the image position. Clear? Let us write the characteristics. Characteristics of image. Characteristics of image. Okay, right. First one, we have to write the position of the image. Where is it formed? Beyond 2f2. So image is formed. The name చెప్తా అంటే beyond 2f2 అంట. Image is formed beyond 2f2. 2f2 కి అవతల ఫామ్ అయింది. నెక్స్ట్ సెకండ్ వన్ సైజు, ఆబ్జెక్ట్ సైజు, ఇమేజ్ సైజు. ఇమేజ్ సైజ్ విల్ బి మోర్ దాన్ ద ఆబ్జెక్ట్ సైజు. ఇట్లా ఉంటే మనం ఏమంటాం అంటే ఎన్లార్జ్డ్ ఇమేజ్ ఆర్ మ్యాగ్నిఫైడ్ ఇమేజ్ అంటాం. ఎన్లార్జ్డ్ ఇమేజ్ ఆర్ మ్యాగ్నిఫైడ్ ఇమేజ్. అండ్ థర్డ్ వన్ యాజ్ యూజువల్ ఇన్వర్టెడ్ ఓన్లీ. ఇన్వర్టెడ్ ఇమేజ్ ఓన్లీ. ఇన్వర్టెడ్ ఇమేజ్. and fourth one, fourth one, real image. Fourth one, real image. Okay, right. Note down. So when object is placed between 2f1 and f1, the image is formed beyond 2f2 and enlarged image and inverted image and finally real image. So if you can observe that, in all cases you get inverted real, inverted real, inverted real means convex lens. Convex lens forms inverted and real images. Okay, then let us see. In all cases it is formed real and అన్ని కేసెస్ లో రియల్ అండ్ ఇన్వర్టెడ్ నే ఫామ్ చేస్తుందా లేక డిఫరెంట్ గా ఏమైనా ఉంటుందో లెట్ us see. Okay, right. So this is the fourth case when object is placed between 2f1 and f1. Okay, right. Pause it and you can write down in your notebook. Okay, right. Next, let us go to case 5. So case 5. Okay, when object is placed, ఇంకొంచెం ఫార్వర్డ్ కి తీసుకొస్తాం ఆబ్జెక్ట్ ని. ఆబ్జెక్ట్ పొజిషన్ చేంజ్ చేస్తున్నాం. ఆబ్జెక్ట్ ఈస్ ప్లేస్డ్ బిట్వీన్ 2f1 f1 కంప్లీట్ ఫస్ట్ ఇన్ఫినిటీ, తర్వాత బియాండ్ 2f1 ఎట్ బి 2f1 బిట్వీన్ 2f1 and f1. Now we can place the object at f1 exactly. Okay, right ma. So object is placed exactly at f1. When object is placed at f1. Okay, object is placed at f1. Okay, right. So again let us take lens, convex lens. Okay, convex lens and principal axis as usual optical center or optic center, first focus point, center of curvature, first center of curvature and second focus point, second center of curvature. But they are giving object is placed at f1 means first focus point. So let us take it is the object here. It is the object position. Object position. So first ray should be taken as parallel. 1 second, Nana. Without scale, you don't draw the ray diagrams in the examination or in case of the practice time also. So first ray is parallel. We know that after refraction, it is passing through the focus point. After refraction, it is passing through the focus point. Exactly passing through the focus point. After refraction, it is exactly passing through the focus point. Okay, done. Next, if it is passing through the second ray, passing through the optical center, it is undeviated. Optical center, it is undeviated. Okay, when light ray is passing through the optical center, it is undeviated. So undeviated. Now, if you can observe that, మీరు బాగా observe చేస్తే, see, these two are parallel rays. మీరు extend చేసినా ఎక్కడ meet అవ్వవు. So if you can observe that the distance between these two rays are same at anywhere. That means these two rays are parallel rays. స్టార్టింగ్ కేసులో ఒక విషయం చెప్పాను ఏంటది, లాంగ్ డిస్టెన్స్ ఆబ్జెక్ట్ నుంచి వచ్చేటటువంటి రేస్ వాట్ ఎవర్ ఇట్ మే బి ప్యారలల్. సో అట్ ద సేమ్ టైం ప్యారలల్ రేస్ వచ్చాయి అంటే ప్యారలల్ రేస్ ఎక్కడికో అట్లా వెళ్తున్నాయంటే ఇమేజ్ ఇస్ ఫార్మ్డ్ ఎట్ లాంగ్ డిస్టెన్స్. దట్ మీన్స్ నౌ ఇమేజ్ ఇస్ ఫార్మ్డ్ ఎట్ ఇన్ఫినిటీ. ఓకే, దోస్ ఆర్ ద క్యారెక్టరిస్టిక్స్. సో క్యారెక్టరిస్టిక్స్ of image here. Okay, first one, image position. Image is formed at infinity. Image is formed at infinity. Understand? If object is placed at focus point, image is formed at infinity. What is the first case? If object is placed at infinity, image is formed at focus point. Okay, right. Next, the second one, size enlarged, highly enlarged, highly enlarged. And the third one, inverted only, below the principal axis only it is formed. So inverted image. And fourth one is real only. It is also real image. This is the first case. Fifth case. So when object is placed at focus point, image is formed at infinity, highly enlarged, inverted image, real image. Till now we got In all cases, inverted image, inverted or real, inverted or real. Okay. But if object position is changed, then image position is also changed. Then image size also changed till now. అంటే ఇప్పటి వరకు మనం చూసిన రే డయాగ్రామ్స్ అన్ని కూడా ఆబ్జెక్ట్ పొజిషన్ చేంజ్ చేస్తుంటే ఇమేజ్ పొజిషన్ కూడా చేంజ్ అవుతుంది అండ్ ఇమేజ్ సైజ్ కూడా చేంజ్ అవుతుంది. బట్ ఇన్ ఆల్ కేసెస్ స్టిల్ నౌ ఇన్వర్టెడ్ ఇమేజ్ రియల్ ఇమేజ్ ఫామ్ అయింది. ఓకే డన్. సో లెట్ us go to లాస్ట్ కేస్. సో నోట్ డౌన్ మా, నోట్ డౌన్. Right, right. So let us go to last one, case 6, most important, case 6, case 6. So when when object is when object is placed when object is placed ఉండనా ఆబ్జెక్ట్ పొజిషన్ ఫార్వర్డ్ చేస్తున్నాం. ఇప్పటి వరకు F1 దాకా వచ్చాం. Now F1 and optic center, between F1 and optic center. So when object is placed between F1 and optic center. So placed between focus point and optic center. Okay, between focus point and optic center. So F1 and optic center. Okay, clear? Right. Let us draw the ray diagram for that case. And when object position is between F1 and optic center, optical center or optic center, then what is the image formed? So let us take lens and principal axis and optic center. So focus point and 2F1 center of curvature, and this side another focus point and the center of curvature 2F2. Okay, they are giving object is placed between F1 and the optic center. So F1 and the optic center. So let us take this is the object position. So let us take this is the object. Object is placed between focus point and the optic center. Object is placed between focus point and the optic center. Okay, focus point and optic. First ray as usual, parallel ray. After refraction it is passing through the focus point only. Clear? As usual, first incident ray is parallel to the principal axis after refraction passing through the focus point. మీరు అబ్జర్వ్ చేసారా, అన్ని 6 కేసెస్లో 2 డయాగ్రామ్స్ తీసుకుంటున్నాను, సారీ 2 రేస్ ఓన్లీ కన్సిడర్. సో మీకు ఈజీగా ఉండడం కోసం ఆల్ 6 కేసెస్లో రెండు రేస్ ఉన్నాయి. ఒకటి ప్యారలల్, రెండు ఆప్టిక్ సెంటర్. అన్నింటికి అంతే, ఒకటి ప్యారలల్ ఆప్టిక్ సెంటర్, ప్యారలల్ రే పాసింగ్ త్రూ ది ఫోకస్ పాయింట్. ఆప్టిక్ సెంటర్ అసలు నువ్వేం చేసేది లేదు, అన్డివియేటెడ్. ఓకే, రైట్. నెక్స్ట్, సో సెకండ్ రే పాసింగ్ త్రూ ది optic center. So you know that the ray which is passing through the optic center, it is undeviated. మీరు స్కేల్ తో డ్రా చేయాలి. ఓకే, it is undeviated like this. So you have to use scale, and if it is wrong, erase. That means use the eraser also. Okay, done. So optic center, any ray passing through the optic center, it is undeviated. It is undeviated, right Nana? So like previous case, when object is placed at F1, these two rays are parallel. But if you can observe that these two rays are not parallel now. చూడండి, ఇవి రెండు డైవర్జింగ్ రేస్, ఇది ఇలా వెళ్తుంది, ఇదేమో ఇలా వెళ్తుంది. ఓకే, ఈ రెండు డైవర్జింగ్ రేస్. సో ఇఫ్ యూ కెన్ అబ్జర్వ్ దాట్, ఇఫ్ యూ కెన్ ఎక్స్టెండ్ ఇట్ బ్యాక్ లైక్ దిస్, సో ఇఫ్ యూ కెన్ ఎక్స్టెండ్ ఇట్ బ్యాక్ లైక్ దిస్ విత్ స్కేల్, అంటే ఈ రేని ఇలా బ్యాక్ ఎక్స్టెండ్ చేస్తున్నాం. ఓకేనా, ఇఫ్ వీ కెన్ బ్యాక్ extended back like this ray, and this can be also like extended back. So I can extend it like this. దీన్ని కూడా బ్యాక్ ఇలా ఎక్స్టెండ్ చేస్తున్నా. ఓకే, ఇలా బ్యాక్ ఎక్స్టెండ్ చేస్తున్నాను. ఇలా బ్యాక్ ఎక్స్టెండ్ చేస్తే దీస్ టూ రేస్ ఆర్ మీట్ ఎట్ వన్ పాయింట్. ఓకే, ఇక్కడ మీట్ అయినాయి చూడండి దీస్ టూ రేస్. ఓకే, సో these two rays meet at this point. Okay, So now here the image is formed like this. Here the image is formed like this. ప్రీవియస్ కేసులో ఎక్స్టెండ్ చేసినా మీట్ అవ్వవు, బట్ ఇక్కడ మీరు ఎక్స్టెండ్ చేస్తే మీట్ అయ్యే ఛాన్స్ ఉంది. మీట్ అవుతాయి ఎందుకంటే బికాస్ దీస్ ఆర్ డైవర్జింగ్ రేస్. ప్రీవియస్ కేసులో ప్యారలల్ రేస్ ఫామ్ అవుతాయి. ఓకే రైట్. సో నౌ ఇట్ ఈస్ ద ఇమేజ్. రైట్ నాన్న, లెట్ us write characteristics of image. Characteristics of image. నాన్న ఇక్కడ చూడమ్మా, characteristics. Image is formed నాన్న B and F1, between F1 and 2F1, B and 2F1, no need to write like that. ఇక్కడ ఏం రాస్తామంటే ఇమేజ్ ఈజ్ ఫార్మ్డ్ సేమ్ సైడ్ ఆఫ్ ది ఆబ్జెక్ట్. అండర్స్టాండ్? ఇక్కడ మనం ఇమేజ్ ఈజ్ ఫార్మ్డ్ సేమ్ సైడ్ ఆఫ్ ది ఆబ్జెక్ట్ రాస్తాం. అంటే లెన్స్ కి సేమ్ సైడ్ ఫామ్ అయింది. ఇమేజ్ ఈజ్ ఫార్మ్డ్ సేమ్ సైడ్ యాజ్ దట్ ఆఫ్ ఆబ్జెక్ట్. ఆబ్జెక్ట్ ఉన్న సైడే ఫామ్ అయింది. సేమ్ సైడ్ యాజ్ దట్ ఆఫ్ ఆబ్జెక్ట్. సేమ్ సైడ్ ఆఫ్ లెన్స్ యాజ్ దట్ ఆఫ్ ఆబ్జెక్ట్. ఆబ్జెక్ట్ ఉన్న సైడే లెన్స్ కి ఆబ్జెక్ట్ ఎటువైపు ఉందో అటువైపే ఇమేజ్ ఫామ్ అయింది. రెండు సెకండ్ వన్ ఇఫ్ యూ కెన్ అబ్జర్వ్ దట్ సైజ్ హైలీ ఎన్లార్జ్డ్ పెద్ద ఇమేజ్ ఫామ్ అయింది. ఓకే, అండ్ see now you can observe that third point and fourth point. third one if you can observe that it is not inverted image, it is upright image. So third one, upright or erect image. It is also called as the erected image or simply erect. Upright or erect image. And it is not real image, it is formed extended rays. That means it cannot be captured on the screen. This can be seen in the lens. సో ఈ ఇమేజ్ మనకి లెన్స్ లో పెద్దదిగా కనిపిస్తుంది, అంతేకాని ఇక్కడ ఫామ్ అవుతుందని కాదు మీనింగ్. లెన్స్ లో మనకి పెద్దదిగా కనిపిస్తుంది. ఇట్ కెనాట్ బి క్యాప్చర్ ఆన్ ద స్క్రీన్. సో సింపుల్ గా గుర్తుపెట్టుకుని ఎక్స్టెండెడ్ లైన్స్ తో ఫామ్ అయ్యేవేవి కూడా రియల్ కాదు, ఇమాజినరీ. దట్ మీన్స్ ఇట్ కెన్ బి సీన్ త్రూ ద lens. That's why it is the virtual image. Okay, these are the characteristics of the image when object is placed between F1 and O. అంటే ఫోకస్ పాయింట్ కి ఆప్టికల్ సెంటర్ కి, అది ఫోకస్ పాయింట్ కి ఆప్టిక్ సెంటర్ కి మధ్యలో ఆబ్జెక్ట్ ఉంచితే వాట్ ఎవర్ ఇట్ మే ద పొజిషన్ ఆఫ్ దిస్ ప్లేస్, we get the image same side of the lens as that of object. సేమ్ సైడ్ ఫామ్ అవుతుంది. ఆబ్జెక్ట్ ఎటువైపు ఉంటుంది అటువైపు ఫామ్ అవుతుంది. హైలీ ఎన్లార్జ్డ్ అండ్ అప్రైట్ ఇమేజ్ అండ్ వర్చువల్ ఇమేజ్. ఓకే రైట్ నాన్న. సో లెట్ us recall all things one time. సో ఒకసారి చూడండి నాన్న. సో కాన్వెక్స్ లెన్స్ ఫార్మ్స్ రియల్ అండ్ ఇన్వర్టెడ్. am I right? Real and inverted. 1 to 5, case 1, case 2, case 3, case 4. That means up to F, up to focus point, whatever it may be the position of the object, we get real and inverted images are formed. That means second side of these real and inverted is formed. But in this case, when object position is between F1 and optical center, we get virtual and erect also. That means convex lens forms both real and inverted images. Convex lens forms both real and virtual images, inverted and erected images. Okay, as well as మీరు అబ్జర్వ్ చేస్తే diminished images form అయినాయి. am I right? Diminished images form అయినాయి and enlarged also formed and same size also formed. am I right? And same size. ఎక్కడ సేమ్ సైజ్ ఫామ్ అయింది మనకి? when object is placed at exactly center of curvature, that means 2f1, image is formed at 2f2, same size. అంటే కాన్వెక్స్ లెన్స్ రియల్ ఇమేజెస్ ని ఫామ్ చేస్తాయి, వర్చువల్ ఇమేజెస్ ని ఫామ్ చేస్తాయి, అండ్ ఇన్వర్టెడ్ ఫామ్ చేస్తుంది, ఎరెక్ట్ ఫామ్ అయ్యే ఛాన్స్ ఉంది. సో డిపెండింగ్ ఆన్ ద పొజిషన్ ఆఫ్ ది ఆబ్జెక్ట్, సమ్ టైమ్స్ వీ కెన్ గెట్ diminished images or enlarged images or same size images. Okay, So these are the ray diagrams and their characteristics of image formation on convex lens. Okay, right, Nana.